State of a system. State of a system is the condition of a system in terms of temperature, pressure and volume etc. is called as state of a system. It means that a system is described by certain macroscopic properties like temperature, pressure, volume, enthalpy, energy and entropy. Now state may be initial state or it may be final state. Initial state is the condition of a system before a change occurs in the system is called as initial state. In initial state, temperature, pressure, volume, energy etc. are represented by T1, P1, V1 and E1. Final state is the state of a system after some change, and in these cases the temperature, pressure, volume and energy are represented by T2, P2, V2 and E2. A system initially has volume V1 and temperature T1. After heating, its volume will become V2 and a new temperature after heating is T2. Now state variables are state properties. Those properties which describes the state of a system are called state properties or state variables or state functions. State function is the function or property of a system whose value depends upon the initial and final state and is independent of the path followed by the system. For example, the existence of a system at one place and then after the change at the final place. Now this may occur in two different ways. For example, I have written a general example that if we start converting A in directly into D, now this process occurs in two different ways. A may be converted indirectly into D, or A may be converted into B and B converts into C and then C converts into D. Now in both the cases the final and initial state of the systems are same. Initially there is A. If you carry out the change in a single step, if you carry out the change in multiple steps, the path is changed, but the initial and final both the states of the system are same. So it depends upon initial and final state, but it doesn't matter by whatever means you carry out the reactions. It has nothing to do with the path, nothing to do with the various steps which are occurring in such type of reactions, but it deals only with the initial and final state of the system. Characteristics of the state functions that it is the property of only the present state of the system and is independent of the way or independent of the path adopted to bring about the change. It is not necessary to specify all the state functions. If a system is identified by temperature, volume and pressure, then by knowing temperature and volume we can find out the value of pressure by using ideal gas equations for gases only. So PV is equal to nRT, so we can easily rearrange the equation and we can obtain pressure from this reaction. When temperature and volume are assigned to 1 mole of an ideal gas, then such type of equations can be used to find out the pressure as well. Then we can calculate P by using this equation. Previously it was the state function which doesn't depend upon the path followed but only depends on the initial and final state, but now we have a path function which depends upon the path followed during the chemical process or during the change in occurring in the system. Now the functions or properties which depends upon the path is called as path functions. Heat and work are path functions and not state functions. Both depends on the manner in which the change is made. Now what is internal energy? It is the total energy of a system, that is the sum of kinetic energies plus potential energy of the system, that is called as internal energy. It is the sum of all possible kinds of energies of a system. For example, if you write down that internal energy, so internal energy is equal to kinetic energy plus potential energy. Now kinetic energy may be in three types. For example, kinetic energy is translational kinetic energy, it may be vibrational kinetic energy, or it may be rotational kinetic energy. So all the three kinetic energies are possible in the molecules. So the addition or the sum of all these possible kinetic energies of the molecules along with their potential energy, that is called as the total internal energy of the system. Now how you have to measure the internal energy? So let's remember that it is different to measure the absolute value of internal energy. You cannot measure the absolute value of internal energy, but you can measure a change in internal energy because the system changes from initial state to final state, so there must be a difference. So that difference can be measured, and that difference is measured along according to this equation, that delta E is equal to E2 minus E1, where delta E is also a state function because it depends upon the initial state and final state only, but it is independent of the path followed. The increase in internal energy of a system has three possible results. It can increase the internal energy of the system by increasing the kinetic energy of the molecules. It can result in phase change like evaporation of water, melting of ice. It may bring about a chemical reaction. When the increase in internal energy is sufficient to break the bonds, then a chemical reaction can occur. Now all these three possible changes may occur when you change the internal energy of the system. By changing the internal energy of the system, it's only going to increase the kinetic energy of the molecules, or a phase change may occur, or a chemical change may occur. Now all these are the possible results of increasing the internal energy of the system.